Hi guys, in this session I would like to talk about data structures in R programming language. So being a data analyst or data scientist, you must be knowing the various kinds of data structures available in the programming languages. So R is itself not declared of any data type, so it's get the data type of the R object whenever it is assigned to it. That means we can say R is a dynamic programming language. So you can change the data type of the same variable again and again in the program. So data type means which specifies the type of value it holds. So whenever we declare variable, you can assign the value. So based on the assignment of the value, the data type is decided in R programming language. Also similarly in Python programming language. And also based on the data types, like you can have mathematical operations, relational, logical operators, so it can be applied on the variables. So R importantly supports 6 data structures which are listed here: vectors, matrices, arrays, data frames, factors, and lists. So let us learn this practically. So the first one is a vector. So vector is a one-dimensional data structure, and it is a very fundamental data structure in R programming, and it has 6 types. The first type is logical. So logical means it stores only true or false, and the second is numeric, means it holds both the positive number and negative numbers. And also the number is a real or float type, like 7.114556.12. And integer, for integer you need to specify no the positive or negative whole numbers by using the character L, so long integer. And then complex number, so R also supports the complex number. As you know, as per mathematics, the general form of complex number is x plus yi. That means it's a real number and also imaginary number, right? And as per mathematics, the value of I is square root of -1. So you can write like this: 4 plus 3i. And character type is also there. So in R programming, you can use single quotes or double quotes. So now basically single quotes represents the single character in other programming languages, and double quotes represent the sequence of characters. So we say string, but here you can use either single quote or double quotes. There is no issue. And it also supports the raw data type. So that means here I'm using hello, so this hello is converted to raw data types. I'll show you this how to create the raw data type. Means the data type is selected, right? The data type is selected and it is converted into unknown format. It is converted into unknown formats. So for example, so here we have vector num1, so the value is 2.35, and we are checking the type of number 1. You can see number 1 is created, and its type is if you put a pointer over there, it says the data type, which is numeric. So here also it is printed, so it is double type, numeric and double type. And then num2, and assigning the value to L. And when you run this, so now the data type of this is no integer. Understand? It is integer type. And here this is character, and character, the value assigned is capital C here, and we are checking the type of character, so which is character type. And string, so here I'm saying str is equals to hello, then checking the type of variable, and it is no character type. So either you can use single quotes or double quotes, there is no issue. And then I'm creating a complex number here. Cn is a user defined variable, and assigning the value 2 plus 3i, and then checking the type of Cn. So this is complex number. Understand? Cn is complex. Similarly, uh, this is raw data type. I'm converting the string Kumar into raw type, checking the type of no R and also printing the value of R. So you see, it's a raw type, and the value Kumar converted into no unknown format. So that is 6B756D6172. And we can also use a class instead of using no type of. You can also use class of R. So the class of R is a raw. And here I'm creating a logical type. So B1 is equals to false. So then checking the type of B1, and it is a Boolean type. Okay, B1 is false here, and it is the data type is what is the data type? It is sorry, there is some mistake here. It is logical. Okay, it is logical type. And you can create a list of no values, like list of vectors, like you can use C. C is a user defined function, sorry, predefined function. C stands for combine. So you're combining these values 1 2 5 3 6 minus 2 4, and then assigning these to A. So here we can say A is numeric vector, and similarly B, which is now having the elements of type string. Then C is a vector, but its values are no logical type, true or false. So these three types of vectors can be created, and we can see that as well here. So for example, here a logical vector is created. Here A is a numeric vector, so we are checking the class of A, it is numeric. And then we are having strings, then checking the class of B, which is character type here. Then C, we are having the L values or Boolean type, so then it is logical type. And vectors can also be added, like here have vector 1 and vector 2, then adding these two vectors, then the result is sum of 1 plus 2, which is 3, then 2 plus 3, which is 5, and 3 plus 4 is 7. So this is how the vectors are created. Understand? So how the vectors are created. And the scalar operator, scalar vectors can also be there. That means which holds a single value, like f is equals to 3, f is equals to 3, and g is equals to us, and h is equals to true. So these three are called as scalar type. And we can use colon. So colon is a shortcut notation, like for example, we would like to have the numbers 1 to 5, and you can use the colon. So 1 colon 5, then this will give us the values 1 to 5, means this is equivalent to this. So colon operator can also be used. So here I'm creating vector 3, which is equals to C of 1 to 5, and then displaying the value of V. So you can see the values 1 2 3 4 5, and these are the scalars, scalar vector. Now, so once you have created a vector, the question is, how do you access elements? How do you access elements? So here you need to specify the position. Let's say A is a vector which is having these numbers, right? And after that A of 1, A, then in the square bracket you need to specify the position. Then A of 1 is the first number, which is 1 here. And this is no accessing multiple elements, but you are specifying the positions, like 3 to 3 comma 5. This is not 2, the position 3 element and the position 5th element. So we'll be getting their values, like the position 3 element is, this is 1 2 3, which is 5, and then positions 5, position 5 means this is 4 and this is 5, so you are getting 6. So you need to specify the position. And this is another example. I'm creating a vector, but the values are string type, then they're saying names of 1, so we'll be getting the output as ABC here. You can see ABC. and names of 3 is KLM, right? The names of 3 is KLM. And here checking the type of names, so this is a vector but which is of type character, and then right, and class of F. What is F? F is a vector but which is having a numeric value here. So here we have created scalar type. Scalar is also vector type, right? But which holds single value. And no, here creating a variable, I think we have already done this over here. A to C of 1 to 5. Got it. So this is about vectors. So I just give a quick review. So vectors are created by using just defining the set of elements, right? And when you want to have multiple elements, you have to use the predefined function C for combine, right? And based on the values, you can have the vector of different types. Even these vectors are heterogeneous type. That means you can have any type of values. Instead of just numeric, you can be having the combination of characters, combination of strings, combination of double type. So that is possible. Then the second data structure or data type is matrices. So matrix is a two-dimensional data structure in which you are having a rows and columns. So here I'm creating a vector. So vector is equals to combining the values 1 2 3 4, and then in the next step I'm creating matrix of vector. So matrix is created from vector. We can specify the parameters like number of rows 2, number of columns 2. Here the number of based on the number of elements, you can specify the number of rows, number of column values, right? So if it here we have 4 elements, so 2 by 2 is 4, right? So elements in the matrix of must be of same type. So whether it can be numeric, character or boolean, but the elements must be of same type. So let us take an example, and here you see so I'm creating a matrix. Understand, I'm creating a matrix here. So vector is this. So from the vector the matrix is created, and I'm specifying the number of rows and columns explicitly. So when you run this, you can see the output 1, then in the second row you have 2, then in the first row 3 4. Here the point to be noted is by default it is column wise. That means the first column is filled, then it goes to the second column, then it goes to the third column, like this. So by default the elements are filled in the matrix based on column. And when you write the the parameter by row is equals to strip, then first row is filled, right? First row is filled 1 2, then in the second row 3 comma 4. If you write by row equals to false, so no need to write this because it is by default column wise. So 1 2 3 4. And here this is another example. The matrix can be created by using combining the elements like 1 to 4. 1 to 4 means 4 elements. So we are specifying the number of rows 2, number of columns 2. So this gives the same matrix 1 2 3 4. And here my data values are 1 to 6. So there will be 6 elements. Then I can specify the number of rows 2 and number of columns 3. So 2 by 3 is 6. So 2 rows but columns are 3. So you can see by default it is filled column wise. So 1 2, then second column 3 4, then third column 5 6. And then how to access the elements of the matrix. So similar to the vectors, you need to specify the position. So mat of 1. So before comma specifies the row, and after comma specifies the column. So mat of 1, in the mat of 1 you have the row, right? That is here mat 1, right? So this has to be created, and then we are specifying mat, otherwise let's say mat 1, matrix 1, matrix 1. So in the matrix 1, the first row is 1 3 5. And here before comma we have not specified anything, right? So no conditions on row, but we have specified the column number. So column 2, that is 3 4, you'll be getting the output for this 3 4. So this is the output 3 4. Then this is a row number and column number. So we are mentioning that 1 comma 2. So row number 1, the first row, and column number 2. So we are getting 3 as the output. So the output is 3 here. So this is how to create a matrix and how to access the elements of that, right? And next, how to create an array. Understand how to create an array. So this array is similar to the matrix, but these are used for more than 2 dimensions. Example here, vector 1, in which we have 3 elements 5 9 3. Then vector 2, 6 elements are there, right? And from vector 1 and vector 2 we are creating a matrix, sorry, array. So result is equals to array of, and combining the vectors vector 1 and vector 2, and also specifying the dimension here, 3 comma 3 comma 2. So 3 elements. So this is going to be just a second. Yep. So we are creating vectors, so 2 vectors, and then from this creating a array. So you see there are how many elements are there? There are 2 elements. So 3 comma 3, 3 rows, 3 columns. Then the third parameter specifies the number of elements. So there are 2 elements. Understand? The same element is repeated. The element in element 1 and also elements in 2 are same, 3 copies. So this is how many dimensional? It is 3 dimensional. Understand? It is 3 dimensional. So from the result you can specify the result. You can access the elements like 1 comma 2 comma 1. That means from the element 1 you're accessing row 1 column 2. Okay, row 1 in the first column. So in the 1 comma 2, 1, and this is 2. So that is 10. 10 is the output in the first element. This one is row number 2, no conditions on column, right? That means we are getting elements, all the elements, and then no conditions on the elements also. That means from both the elements we are getting the no, we are getting row number 2. We are getting row number 2 from here. So rows. So row number 2, all columns, right? We're getting all columns. And then this one is 1, row number 1, column number 1, but the element is 2. So you're getting the resultant value as 5. Is it clear? So row number 1, right? Row number 1, and column number 1 means this one, and element number 2. So as we have same elements, so this is the result here. So like this you can access the elements of array. Next, the fourth data structure is data frames. So data frames are heterogeneous type, right? So these are the most commonly used data structures, right? And whenever you have the data in different formats like CSV or any other format, you can just load the data and then the data frame is created. So but you can see it's heterogeneous type. It means each column can contain different modes of data. So here I'm creating vectors, name, gender here, and age. So from these 3 variables I'm creating a data frame. So I'll show you how to do that. So creating a data frame. Yeah, so 3 variables are created. Then from these 3 vectors we are creating a data frame and then displaying the data frame. So these are the 3 rows, right? Row number 1 2 3, and then you can see the column name, gender, age. That means vector names are acting as column names. Understand? Vector names are acting as column names. Then the question is how to access the elements of data frame. Let's say if I want to have the first column, then df means data frame name, then dollar, and then the name of the column. So we are accessing the name. So Joy, John, and Nancy. Then A's, so you will be getting the A's column, 27, 26, 26. Then DF dollar names of 3, that means third value from the name, so we are getting Nancy as the output here. When you run this line, the output is Nancy. So like this you can access. Then DF, you can also write like this, DF of combining 1 comma 3, that means accessing column 1 and column 3, that means name and A's. So name and A's are the resultant values. And then here 1 to 2, this is slicing, right? 1 to 2, and the no condition on columns. So first 2 rows are the output. And then this is another example. So this is for factors type. And after that, yeah, accessing data frame elements is done. Next, factors. So factors are categorical variables. So like here I'm creating gender, the gender, and the values are like this. So there is a typo mistake here, male, female, female, male. And then one more vector is the status, poor, improved, excellent, poor. So when you convert this into factor types, so you have 2 unique values, males and females. So that means there are 2 levels on gender. Whereas in status there are three unique values, improved, excellent, and poor. So there will be 3 layers, 3 levels. So let us create this. Yep, from this we are creating a converting them to factor types. So you can see the variable factor, and here in the environment you can see 2 levels for F gender and 3 levels for F status. Factor status, you have 3 levels. So it depends on the unique values, you can create a factor type. So this is simple example. Another example, creating a data frame with the fields like employee ID, name, salary. So 3 rows, 3 columns. So employee IDs are generated like combining 1 2 3, then name, 3 names, and 3 salary values. So from this data frame is created. So this is the output. So this is data frame 1, and then we can also create data frame 2. Here the IDs are generated by using colon operator. 4 to 5 means 4 comma 5, then 2 names and 2 salary values. So this is another data frame, and we can also append this data frame 2 to the data frame 1. So in R we have a predefined method, that is R binding df1 and df2, and the result is stored into the data frame 3. So you can see here employee ID 1 2 3 4 5. So both the data frames are combined. Next, how to remove the column. So you can use minus of 1, that means first column is removed and then we are displaying. So employee ID is removed. Understand? So here we are selecting the rows 1 3 4 5, then displaying df of combining the rows. So 1 3 4 5, this is how do you select the rows. So how to access the data frame elements is done, then factors is also done. Next, list. So this is the final data structure. It's the most complex data structure, and it is a combination of vectors, matrices, data frames, even from other list. So like here we are creating a vector, this is a numeric type, and matrix is created from vectors. So 2 rows 2 columns we are mentioning, and then list is created from vector and matrix. So let us take an example for this. And once the list is created, right, once the list is created, let us see how to access the elements. So vector 1 matrix is created from vector, right? If you want, you can also display what is matrix here. So we have 1 2 3 4. So column wise 1 2 3 4, and matrix is created from vector. And then here this is another data frame. So foo is equals to list of, so that means we are creating a list. Foo is going to be a list, and list is created from vector and matrix and displaying the value. So the first element is list, that is 1 2 3 4, and second element is the matrix, checking the class of foo. So this is a list. So in this session we have to learn about the data types. In other terms we can also say data structures, because these holds the values. So data structure means creating a data, right, and then you need to perform operations. So data structure means organizing the data and then performing operations. So we have taken example for these 6 basic type of data structures in R programming. So these are very important because for complex programming the basics of these is required. So that's it from this session. So do subscribe our channel, do like our channel, do comment our channel, and so that you'll be getting relevant videos in near future.